Hi friends, welcome to our YouTube channel Naraj Academy. The main aim of this lecture is to discuss about the mathematics previous year questions of PSUs in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes on mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Please do watch all our videos in the YouTube itself so that our channel can reach to more number of students. I hope you will do it. So let's get started. So now we are going to solve the 41 question. See the question here. For minus infinity less than x less than infinity and minus 1 less than y less than 1, the partial differential equation is. So they have given a partial differential equation and also the range of the x and also the range of the y. So we have to basically find what is the solution of this differential equation and the shape of that we need to figure out. See what is the shape of the solution of this differential equation we need to figure out. So out of this all these options, option C, ellipse or elliptical is the correct solution of this question. So let's solve this numerical. So before I solve this question, let me tell you a small formula, which is a into dou square z by dou x square plus b into dou square z by dou x into dou y plus c into dou square z by dou y square is equal to f of x comma y comma z comma, where p and q. So p is nothing but here dou z by dou x, whereas q is equal to dou z by dou y. So if any differential equation in this format, then we can say that the solution of this differential equation, partial differential equation, can be either of these three formats, which is if b square minus 4ac less than 0. If this is a condition satisfied, then we can say that this is in the form of ellipse shape. Whereas if b square minus 4ac is equal to 0, then we can say that solution of this differential equation, the shape will be in the form of the parabolic form. But if b square minus 4ac is greater than 0, then we can say that the solution of this partial differential equation will be in the form of the hyperbola form. So these are the three forms we can get with the help of this partial differential equation, the solution of that by satisfying either of these three conditions. So now here, this is a partial differential equation in the question they have given. So now we are going to compare this equation with respect to this equation. So now I can write this equation in the terms of another one, which is 0 into dou square u by dou x dou y. So you can see clearly these two equations are same. Only thing I have added an extra parameter or extra term with the help of 0. So if you are going to compare the general equation and the equation in the question they have given, so we can conclude that here a is equal to x square, b is equal to 0 and c is equal to 1 minus y square, whereas z is equal to u and f of this all this function is equal to 0. So by comparing, we only want the coefficient values, which are the a, b and c. So we got the value of the a is equal to x square, b is equal to 0 and c is equal to 1 minus y square. And in the question they are given that the range of the x is from minus infinity to plus infinity and the range of y is from minus 1 to 1. So based on this, we need to, now we have to see which condition is satisfied. So therefore the solution will be in that format. So now a is equal to x square and b is equal to 0 and c is equal to 1 minus y square. So now here I want to know which of these three conditions out of these any one is going to get satisfied. So let me assume b square minus 4ac. I want to know what is the nature of the b square minus 4ac. So if I substitute b, a and c, then I am going to get 0 square minus 4 into x square into 1 minus y square. So here 0 square is nothing but 0. So minus of 4x square into 1 minus y square. And the question also they are given the range of x and the range of y. The range of x from minus infinity to plus infinity and the range of y is from minus 1 to plus 1. So you can see clearly as x square is always a positive value. So x square is always going to give you a positive value. Whereas y square, you can see clearly y square is also positive, but y is going to lie only from minus 1 to plus 1. So therefore definitely the y square value will be always less than positive 1. So therefore this value is always lesser than 1. So 1 minus anything is again 1 minus any value which is less than 1 is again a positive value. So therefore this is also positive value. So therefore positive into positive, so overall value is positive, but there is a negative sign here. So therefore we can say minus into plus is again minus. So overall value, which is b square minus 4ac, is negative. So therefore you can see out of these three only this condition is satisfied. So therefore we can say that the general solution of this partial differential equation will be in the format of the ellipse form or elliptical form. So therefore this is a correct solution of this question. So now we are going to solve the 42nd question. See the question here. The complex valued function f of z is equal to e to the power of z is analytic for. So here basically they are given a complex function which is f of z is equal to e to the power of z, and we need to find in what range of value of z we need to find this function is analytic. Analytic means at what ranges of z the function is defined, that we need to figure out. So out of these four options, option B, which is all the z plane, so therefore at all the points in the z plane this function is defined. So option B is the correct solution of this question. So let's solve this numerical. So now in the question they are given f of z is equal to e to the power of z. We have to know at what range of z the function is analytic. So basically the meaning of analytic is here the function should be continuous at each and every point, and it means that the function should be defined at each and every point, and that range if you are going to collect, that is called as the function is going to get analytic, means at what range of z the function is defined, and also in that range we can say the function is also continuous. So what is that range we need to figure out. So therefore we can see clearly, suppose z is equal to x plus iy, because it is a z plane, so complex plane which is z plane, so therefore z is equal to x plus iy. So in place of z I have replaced x plus iy, so therefore f of z is equal to e to the power of x plus iy. So I can write in this format, which is e to the power of x into e to the power of iy. So e to the power of x into e to the power of iy I can write, which is cos of y plus I sin y. So if I take the e to the power of x inside, I am going to get e to the power of x into cos y plus I into e to the power of x into sin y. So the general format, which is u plus iv, so therefore u is equal to e to the power of x cos y and v is equal to e to the power of x sin y. So if any function, if it is going to satisfy the Cauchy-Riemann equations, then definitely we can say that the function is analytic. So therefore we can say clearly, now I am going to check the two conditions of the Cauchy-Riemann equations, which are the dou u by dou x is equal to dou v by dou y. So if this is satisfied, then we can say the function is continuous. So therefore now I am going to the partial derivative with respect to x for u. So if I do the partial derivative with respect to x for u, I am going to get e to the power of x cos y. Similarly, if you do the partial derivative with respect to y for this function v, we are going to get e to the power of x into cos y. So both the things are equal. So therefore the first condition is satisfied. So now we have to go for the second condition, which is dou v by dou x is equal to minus dou u by dou y. So if you do that v by dou x, we are going to get e to the power of x into sin y minus of, and if you go for the dou u by dou y, we are going to get minus e to the power of x into sin y. So minus into minus is again positive. So therefore you can see LHS is equal to RHS. So both the Cauchy-Riemann equations are satisfied. So therefore we can say the function is analytic at each and every point in the z plane. So therefore simply we can say, no matter whatever the point you take in the z plane, at each and every point in this z plane the function is defined. So if you keep any value out of this z plane in the function e to the power of z, and you are going to get a certain finite value in the w plane. So we are going to convert from z plane to the w plane. So therefore at each and every point in the z plane the function is continuous and also it is differentiable. It means that the function is analytic for each and every point in the z plane. Suppose if you take y is equal to e to the power of x, so you can draw the at each and every value of x the function is defined in this format. So therefore we can say that here at each and every point in the x, so therefore we can say the function is defined. Similarly here y is equal to f of z is equal to e to the power of z at each and every point in the z plane. To take each and every point in the z plane, keep it here in this equation, you are going to get a certain finite value in the w plane. So therefore we can say the function is defined at each and every point in the z plane, and also it is continuous and also it is differentiable. So simply we can say that the function is analytic for all the z plane. At each and every point in the z plane the function is defined. So now we are going to solve the 43rd question. See the question here. The orthogonal trajectory of the family of curves which are x square minus y square is equal to alpha, where alpha is a constant and passing through the point 1, 1 is. So basically they are given some curve and we have to find what is the orthogonal trajectory for this given graph we need to figure out. And also that graph, that particular point, that particular graph is going to pass through 1, 1, we need to figure out. So out of these 4 options, option B, y is equal to 1 by x is the correct solution of this question. So let's solve this numerical. So now basically in the question they are given that x square minus y square is equal to alpha. So for this graph we have to find what is the orthogonal trajectory. Basically means the perpendicular graph we need to figure out, and that particular graph is going to pass through 1, comma 1. So what is the equation of that graph we need to figure out. So basically to figure out that we have to find what is the slope of this graph we need to figure out. So in order to get the slope we have to find the differentiation with respect to x we need to figure out, which is if you do the differentiation with respect to x we are going to get 2x minus 2y into dy by dx is equal to 0 because alpha is a constant value. So if you take this part to the RHS we are going to get 2x is equal to 2y into dy by dx. So if you solve this one we are going to get dy by dx is equal to x by y. So this is the slope of this graph. But when the two graphs are orthogonal, we can say that the product of the slopes is equal to -1. So because of that, m1 into m2 is equal to -1, and the slope of the first graph is which is x by y, and we have to find what is the slope of the second graph, which is m2 is equal to -1. So if we rearrange this one, we are going to get the slope of the second graph, which is -y by x. Slope is nothing but it is a dy by dx is equal to -y by x. This is the slope of the orthogonal trajectory. So now we have to do if we have to find what is the general solution of this differential equation, we need to figure out, which is dy by dx is equal to -y by x. So now I am going to take the y to this part, means I am going to rearrange in this format, which is like variable separable method, which is -1 by y into dy is equal to 1 by x into dx. So if you do the integration on the LHS and RHS, we are going to get minus ln y is equal to ln x plus ln k is a constant value. So therefore here log m plus log n is equal to log m into n. So therefore log of x into k. So minus I can take inside, I am going to get ln of 1 by is equal to ln of xk. So we can compare both of things, we are going to get 1 by y is equal to xk. But these are the general format of curves which are perpendicular to the original equation. But we have to get only one graph which is going to pass through 1, 1. So if you substitute x is equal to 1 and y is equal to 1 in this equation, we are going to get finally 1 by 1 is equal to 1 into k. So therefore k is equal to 1. So if you substitute k is equal to 1, we are going to get 1 by y is equal to x or y is equal to 1 by x. So this we are going to call it as the rectangular hyperbola. So therefore the graph which is perpendicular to the x square minus y square is equal to alpha, and it is passing through 1, 1, which is y is equal to 1 by x. It is basically a rectangular hyperbola. So now we are going to solve the 44th question. See the question here, the system of equations. So they are given the 3 system of equations with the 3 variables x, y and z. We have to find what is the nature of the solution of these 3 equations. We need to figure out whether unique solution or infinite solutions, or there is no solution, or none of the above. So out of this we can say that only option A is the correct solution of this question, which is a unique solution for these 3 equations. So now we are going to solve the numerical. So here in the question they are given 3 equations, which are the x plus y plus z is equal to 6, and 2x plus y plus z is equal to 7, and x plus 2y plus z is equal to 8. So for these 3 equations we have to find what is the nature of the solution. We need to figure out. So in order to find the nature of the solution, first we have to find what is the augmented matrix, means the coefficients of this matrix and also these coefficients x, 7, 8. So I have taken all the coefficients which are the 1, 1, 1, 6, 2, 1, 1, 7, 1, 2, 1, 8. So I have written this augmented matrix, which is A bar B. So now here I want to convert this into row echelon form. So therefore I want to convert this graph in this matrix into row echelon form, means here I want to make this term as 0, this term is also 0. See, I can make this term as 0 only if I rearrange R2 with respect to 2R1 minus R2. Then only I can make this value 0. Similarly, I can make this value 0 only when if I go for R3, if I am going to replace R3 by R3 minus R1, then only I can get this value as 0 and this value as 0. So if I do the simplification, finally I am going to get the new rows of R2 and R3, which is the format of the 1, 1, 1, 6, 0, 1, 1, 5 and 0, 1, 0, 2. And similarly again I want to make this value is also again 0, then I have to do for the R3 minus R2. So therefore I am going to get a new row of R3, which is R3 minus R2, and if you do the simplification, finally we are going to get which is 1, 1, 1, 6, 0, 1, 1, 5 and 0, 0, minus 1, minus 3. So this is in the 0 format and this is also 0. So always in the diagonal, the data which is present behind the diagonal terms, we have to make it as 0. So this is called as the row echelon form. So finally we got a matrix in the term of the row echelon form. So now we have to see how many number of non-zero rows are going to get present in this matrix we need to figure out. So this is the matrix A. This is the matrix A and this overall matrix is called as the A bar B. So you can see clearly the number of non-zero rows for matrix A is 3 and the number of non-zero rows for matrix A bar B is again 3. So we can say that the rank of A is equal to rank of A bar B is equal to 3 because the number of non-zero rows. So 3 we are going to call it as the number of unknowns, which are the number of unknowns are x, y, z. So therefore simply we can say that the rank of A is equal to the rank of augmented matrix is equal to the number of unknown variables. So simply we can say this we are going to call it as it is going to exist only unique solution. So the condition is, suppose here a solution is going to get means the system is going to have only consistent means solution only when rank of A is equal to rank of A bar B. If it is equal to number of unknown variables, then we are going to have only unique solution. But if the rank of A is equal to rank of A bar B augmented matrix, but if it is less than n, it indicates that here there are infinite number of solutions. But if rank of A is never equal to rank of A bar B, then definitely we can say that there is no solution. So only the first equation is satisfied. So simply we can say that only a unique solution is going to exist for these equations. And if you want to know what is that unique solution, then you can simplify this circuit. You can simplify this equation, which is x plus y plus z is equal to 6, y plus z is equal to 5 and minus z is equal to minus 3. So you can solve these three equations. So z is equal to 3, and if you keep z is equal to 3 in this above equation, we are going to get the value of y, which is 2, and you know the value of z, you know the value of y. You can substitute in the first equation, and if you do simplification, finally you are going to get the value of x, which is equal to 1. So therefore x comma y comma z is equal to 1 comma 2 comma 3. If suppose in case if they ask what is the unique solution particular value, then 1 comma 2 comma 3 is the correct solution. So blindly we can say that we have to check out of this which is going to get satisfied, and based on that we have to check for the result. So only unique solution is going to exist for this equation. So now we are going to solve the 45th question. See the question here. The solution of the differential equation is, they are given a differential equation, just we have to find what is the solution we need to figure out, or general solution we need to figure out, which is dy by dx is equal to e to the power of x minus y plus x square into e to the power of minus y. So this is basically the differential equation. For this differential equation, we have to find the general solution. So out of the four options, option A is the correct solution of this question. So let's solve this numerical. So this is the differential equation they have given, which is dy by dx is equal to e to the power of x minus y plus x square into e to the power of minus y. So for this we have to find the general solution. So now if you see clearly here, I can write which is here e to the power of x into e to the power of minus y plus x square into e to the power of minus y. So I can take e to the power of minus y is a common term, so I can take it outside. I am going to get e to the power of x plus x square. So now I can take this e to the power of minus y, I can take to this side, so therefore you are going to get e to the power of y into dy, and I can take the dx this side, we are going to get e to the power of x plus x square into dx. This is called as a variable separable method, means we are going to keep y terms one side and the x terms another side. So this is called as a variable separable method. So now here simply we can say that here now I am going to do the integration with respect to both the sides. I am going to do, so therefore here we are going to get e to the power of y, here we are going to get e to the power of x plus x cube by 3 plus c, because integration of x to the power of n is equal to x to the power of n plus 1 by n plus 1. So by using this formula we are going to get this is the general solution of this differential equation we are going to get. So this is a correct solution of this question. So this is a general solution of this differential equation. So now we are going to solve the 46th question. See the question here. The value of the integral, which is sin z by z cube around the circle mod of z is equal to 2. So basically they are given some integral, the closed loop integral around the curve which is mod z is equal to 2. The function which is sin z by z cube we need to figure out. So out of these four options, option B 0 is the correct solution of this question. So let's solve this numerical. So here they are given a integration, means we have to do the integration in a closed loop which is sin z by z cube dz we need to figure out. So here they are given the curve which is mod z is equal to 2. So z is equal to x plus iy. The modulus of that is nothing but under root over x square plus y square is equal to, if I take the square on the both sides, I am going to get x square plus y square is equal to 2 square. So it is basically a circle of center 0, 0 with a radius of 2. I am going to get in this format in the z plane of a center of 0, 0 with a radius of 2. So we can simply say that here we have to find what is the integral over this curve we need to figure out. So on this line integral, on this closed line integral, what is the closed line integral of this function around this path we need to figure out. So this is the closed line integral. So now here, now the basic theorem, which is the Cauchy-Riemann or Cauchy-Residue Theorem, which is the Cauchy-Residue Theorem, states that the closed line integral of f of z into dz is equal to 2 pi I into sum of the residues. Means at those points, if the function is singular, and these are inside the closed line integral, then we have to take only that, then we have to take the residues at those singular points we have to take. So if you take here, this is called as the poles of this equation, which is z is equal to 0. If you substitute z is equal to 0 in this equation, anything by 0 is again infinity, means it is not defined. So therefore, if you substitute in place of z, if you substitute at z0, so if you replace z by z0, at those points of z0, if f of z tends to infinity, then we are going to call these points as the singular points. So therefore, if at any point of z0, if the function is going to tend to infinity, then we are going to call that points as a singular points. So z is equal to 0. This singular point is going to make this function to infinity. So these are called the singular points. So there are 3 singular points, which are the 0, 0 and 0. So these are 3 singular points. So now the basic way to find the coefficient, the basic way to find the residue for the singular point, which is limit z tends to z0 1 by k minus 1 factorial into d by dz at the power of k minus 1. So means k minus 1 derivative with respect to z of z minus z0 all to the power of k into f of z. So now the singular point is now 0. So here z0 is equal to 0 and the function f of z is sin z by z cube, where k is called as the order of that pole. So of the order of that singular point, the order is 3 because 3 poles are going to present at origin and these are inside the curve. So therefore you can take here k is equal to 3 and z0 is equal to 0, and if you substitute in this equation, we are going to get z0 is equal to 0 and k is equal to 3. So finally you are going to get in this format. So here z minus 0 whole cube is again z cube. So therefore now z cube and here also z cube, they both are going to get cancelled. So finally this equation is now simplified to limit z tends to 0 1 by 2 into d square by dz square of sin z. So we have to do the 2 times differentiation of the sin z we need to figure out. So sin z, if you do for the first differentiation, we are going to get cos z, and if you go for the second time, we are going to get minus sin z. So therefore 1 by 2 into minus of sin z. So now in place of z, we have to replace the 0. So sin 0 is again 0. So therefore all this value is going to tend to 0. So therefore now simply we can say that here the residue of this pole we are going to get 0. So now we have to substitute in this residue. So we are going to get 2 pi I into 0 is again 0. So therefore the overall integration is going to give you a result of 0. So this is the correct solution of this question. So now we are going to solve the 47th question. See the question here. The maximum value of the f of x comma y is equal to 3xy subject to the constant of 2x plus y is equal to 8. So in this question we have to find what is the maximum value of the function which is f of x comma y, which is 3xy, and the constant is here 2x plus y is equal to 8. Means only the points which are lying on this line, the 2x plus y is equal to 8, at what value of the point x comma y we are going to get the maximum. So therefore we have to find what is the maximum value of this function, and that particular point x comma y should lie only on this line. That is the meaning of this question. So out of these 4 options, option B 24 is the correct solution of this question. So let's solve this numerical. So in the question they are given that the function f of x comma y is equal to 3xy, and also they are given the equation of the line which is 2x plus y is equal to 8. So in the question they are asking here what is the maximum value of this function given the constraint is this one. It means that the point x comma y should lie on this line, and at this value of the point which is going to lie on this line, at what value we are going to get a maximum. So definitely we have to find what is the maximum value of this function we need to figure out, and that point x comma y should lie on this line. So now I am going to say this is a function of x comma y, so I want to convert in terms of only one variable, because f of x comma y is a function of two variables which are the x comma y, but I want to convert this function into a single variable for easy way of simplification. So therefore now y is equal to 8 minus 2x. So in place of y, I am going to replace 8 minus 2x. So therefore overall I am going to get a function only in the variable of x terms. So g of x I am going to assume which is f of x comma y 3x into the value of y which is 8 minus 2x. So if we do a simplification, finally we are going to get which is g of x is equal to 24x minus 6x square. So now for this equation in terms of single variable, we have to find what is the stationary point we need to figure out. So if you want to know the stationary point, we have to go for the first derivative and also second derivative. So now the first derivative with respect to x, we are going to get 24 minus 12x, and if you go for the second derivative, we are going to get minus 12. So if you equate the first derivative is equal to 0, then only we are going to get the stationary point. So we have to find what is the stationary point. So therefore if you equate the first derivative to 0, which is 24 minus 12x is equal to 0, then we are going to get x is equal to 2. At x is equal to 2, whether this function is going to have minimum value or maximum value, because at this value of 2, the slope is equal to 0, but we have to find what is that nature we need to figure out. So we can only get if you know the second derivative at x is equal to 2. So the second derivative is negative, so no matter whatever the x, it is independent of x. So no matter whatever the x, its second derivative is always negative value. So second derivative of the function at x is equal to 2, it is equal to minus 12. So simply we can say that whenever the second derivative is lesser than 0, it indicates that at x is equal to 2, the g of x is going to have a maximum value. So at x is equal to 2, g of x is going to have a maximum value. It simply indicates, but g of x is equal to f of x comma y. So therefore f of x comma y is going to have a maximum value of x is equal to 2 at x is equal to 2. If x is equal to 2, then what is the value of y? Because this x comma y should satisfy they are going to lie on the line, which is y is equal to 8 minus 2x. We know the value of x, which is 2, and if you substitute here in place of x2, and if you solve this one, we are going to get 4. Y is equal to 4. So therefore we got the value of x, we got the value of y, which is 2 comma 4. At this point, which is going to lie on the line, we are going to get the maximum value of the function. So f of x comma y is equal to 3xy. We know the value of x, we know the value of y. Substitute here, and if you do the product, we are going to get 24. So therefore simply we can say that the 2 comma 4 is going to lie on the line at that particular point, at that particular value of x comma y. If you substitute in this function, we are going to get the maximum value of the function. Basically it is a three-dimensional figure. You can visualize this one here. At a particular value of x comma y, we are going to get a maximum value, means we are going to get in this format, that the format we are going to get in the form of a 3D picture. So now we are going to solve the 48th question. See the question here, the sum of eigenvalues of this matrix. So the matrix is A. For this matrix we have to find what is the sum of the eigenvalues we need to figure out. So out of these 4 options, option D, 2 is the correct solution of this question. So let's solve this numerical. So in the question they are given a particular matrix A. So for this matrix we have to find what is the sum of the eigenvalues we need to figure out. So basically sum of the eigenvalues is nothing but it is equal to the trace of the matrix. So sum of the eigenvalues, which is a 3 by 3 matrix, so it is going to have 3 eigenvalues, which are lambda 1 plus lambda 2 plus lambda 3 is equal to, it is called as the trace of the matrix A. Trace of the matrix A means we have to just add the diagonal elements of the square matrix we need to figure out. So if you go for the addition of the diagonal elements, which is 1 plus 4 minus 3, we are going to get 2. So therefore the sum of eigenvalues is equal to, or the trace of matrix is equal to 2. But in the question they may ask what is the product of the eigenvalues, then it is equal to the determinant of the matrix. So if you want to find what is the determinant of this matrix, we are going to get 1 into minus 12, and also here minus 0 plus minus 0 into this is again 0. So therefore here plus 4 into here we are going to get 0 minus 12. So finally you are going to get in this format, and if you do simplification we are going to get minus 12 and minus 48. So therefore overall minus 60. So if you want to know what is the product of eigenvalues, then it is minus 60, and if you want to know what is the sum of the eigenvalues, then it is 2. But in the question they asked only what is the sum of the eigenvalues. So option 2, the solution 2 is the correct solution of this question. So now we are going to solve the 49th question. See the question here. If A is a square matrix of order 3 with its characteristic equation, which is x cube minus 2x square minus x plus 2 is equal to 0, then its determinant is. So basically in this question they are given the matrix of order 3 by 3 and also they are given the characteristic equation. So we have to find what is the determinant of this matrix we need to figure out. So out of these 4 options, option C minus 2 is the correct solution of this question. So let's solve this numerical. So now here they are given a matrix of A with order of 3 by 3 and also they are given the characteristic equation of this matrix also they have given, which is x cube minus 2x square minus x plus 2 is equal to 0, and we have to find what is the determinant of this matrix we need to figure out. So now I am going to solve this question by 2 methods. The first method is here. Basically here this is the cubic equation, so we can find the sum of the roots is equal to, if you want to know what is the sum of the roots, the formula which is minus 1 all to the power of only one term we are going to take at a one time, so therefore it is 1 coefficient of x to the power of n minus 1 by coefficient of x to the power of n. So whatever this term we have to take it minus here. So the coefficient here n is equal to the order of this equation. The order of the equation is 3. So 3 minus 1 which is equal to 2. So therefore, and this is 3. The coefficient of x square, is minus 2 and the coefficient of x cube is 1. So if you substitute in this equation, finally we are going to get the sum of the roots is equal to 2. But if you want to know what is the sum of product of two roots, then finally we are going to get in this format, which is x1 x2 plus x2 x3 plus x3 x1, because it is the order of 3. It indicates that there are 3 roots for this given equation. So now the formula will be minus 1 all to the power of, as we are taking 2 terms, so therefore square coefficient of x to the power of n minus 2 by coefficient of x to the power of n. As n is equal to 3, so we can say that 3 minus 2 is again 1 and this is 3. The coefficient of x to the power of 1 which is minus 1 and the coefficient of x cube is 1 and minus 1 square is plus 1. So if you solve this one, we are going to get minus 1. And similarly, if I want to know the product of 3 roots, which is x1 x2 x3 is equal to minus 1 all to the power of 3 terms we are going to take at a time, so therefore 3 coefficient of x minus 3 by coefficient of x to the power of n. As n is equal to 3, we are going to get 3 minus 3 is 0 and this is x to the power of 3. The coefficient of x to the power of 0 is 2 and the coefficient of x cube is 1. So if you solve this one, minus 1 into 2 by 1 is again minus 2. So simply we can say that here finally we got the product of the roots is equal to minus 2. So now we can say that the determinant of the matrix is equal to the roots of the characteristic equation, or we can say the product of the roots of the characteristic equation. The product of the roots of the characteristic equation are called as the product of eigen values, which is equal to minus 2. So therefore the determinant of the matrix is equal to the product of eigen values, or we can say the product of roots of the characteristic equation, which is minus 2. So minus 2 is the correct solution of this question. So now we are going to solve by another method 2 here. This is the equation, characteristic equation. So now I want to find what is the roots of this equation I need to figure out. So I am going to take all the coefficients 1, minus 2, minus 1 and 2. I have taken everything. See, just I am assuming that x is equal to 1 is a root or not. I am going to check whether 1 is a root or not. I am going to check in this one. So I am going to substitute x is equal to 1. So always the first value should be take here 0. So always you have to take here 0. So therefore 1 plus 0 is 1 and 1 into 1 is 1. Minus 2 plus 1 is minus 1. So minus 1 into plus 1 is again minus 1. So minus 1, minus 1. If you do the addition, we are going to get minus 2. Minus 2 into 1 is again minus 2. So 2 plus 2 minus 2 is 0. So therefore, if you are going to get this value as 0, then definitely x is equal to 1 is said to be a root. Otherwise, it is not a root. So now, x is equal to 1 means I can write x minus 1 into, this is, as it is a 3, so one term we already know. So therefore, the next power is 3 minus 1 which is 2. So therefore x square minus x minus 2 is equal to 0. So I want to find what is the roots of this equation, x square minus x minus 2. So minus 2, I can write minus 2 into 1 which is minus 2 and minus 2 plus 1 is again minus 1. So I am going to reduce this equation into x square minus 2x plus x minus 2. I can take x as a common in the first two terms. So I am going to get x into x minus 2 plus, and if I am going to take 1 as a common, then I am going to get x minus 2. So in these two equations, x minus 2 is again common. So x minus 2 into x plus 1, and there is also x minus 1. So these are the product of the roots. So if you do the product of these three terms, we are going to get the original equation. So if you equate to 0, we are going to get x is equal to 1, x is equal to minus 1 and x is equal to 2. So these are the 3 roots we are going to get, 1, minus 1 and 2. The product of the roots is equal to, just we have to go for the product of these 3 roots, which is 1 into minus 1 into 2, which is minus 2. So therefore we can say, simply say So we can simply say that this is called as the product of roots is equal to -2. It is called as the determinant of a matrix. So the determinant of a matrix is equal to the product of the eigen values, which is equal to -2. So -2 is the correct solution of this question. So you can go for any of the method, still you are going to get the same result. So now we are going to solve the last question of this lecture, question number 50. See the question here: the solution of d square x by dt square plus x is equal to 0 subject to the conditions of x of 0 is equal to 1 and x dash of 0 is equal to -1. So basically they are given a differential equation and also they are given initial conditions, two initial conditions. So based on this we have to find what is the solution of this question. We need to figure out the solution of this differential equation and these conditions we need to figure out. So out of these four options, option C, which is cos t minus sin t, is the correct solution of this question. So let's solve this numerical. So this is the question they are given, which is d square x by dt square plus x is equal to 0. So now here basically the input is equal to 0 means only the output will be always, basically the output will be summation of the complementary solution and also the particular internal solution. But as there is no input, so we can default, we can say that the output is equal to the complementary solution itself. So therefore now I am going to take x as a common, then I am going to get in this format. I am going to assume d by dt as d. So therefore d square is equal to d square by dt square. So like this we are going to get. So I am going to replace d square by dt square is equal to d square. So d square plus 1 into x is equal to 0. So as x cannot be equal to 0, so definitely d square plus 1 is equal to 0. So therefore d square is equal to -1. So d is equal to plus or minus I. So we are going to get in this complex term. So for a plus or minus I be root, the general equation will be e to the power of ax plus into a cos x plus b sin x. When y is a function of x, when y is a function of x, but here x is a function of t. So therefore just replace x by t, we are going to get and y by x. So x is equal to a cos t plus b sin t. So if you want to do the derivative of this one with respect to t, we are going to get x dash is equal to cos derivative is minus sin t and sin derivative is cos t. So also they are given the two initial conditions, because there are two constants. You can only find the two constants if you know the two initial conditions. The initial conditions are x of 0 is equal to 1 and x dash of 0 is equal to -1. So in place of, I am going to substitute the first equation, the first initial condition in this equation, which is x of 0 is equal to 1. So t is equal to 0 and x is equal to 1. So if you substitute x is equal to 1 and t is equal to 0, we are going to get a plus 0 is equal to 1. So definitely a is equal to 1. So if you substitute the second initial condition, which is x dash of 0 is equal to -1. So therefore t is equal to 0 and x dash is equal to -1. So if you substitute this equation, we are going to get -1 is equal to 0 plus b. So b is equal to -1. So finally we got the value of a is equal to 1 and b is equal to -1. So if you substitute this final equation, then we are going to get the solution as a is equal to 1 and the b is equal to -1. So this is the solution of the question of this differential equation. So this is the correct solution of this question. So by this lecture, we have successfully completed the 50 questions in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload new video, the direct notification comes on mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely do all those improvements in the coming lectures. Please do watch all our videos in the YouTube itself, so that our channel will grow and it will reach to the more number of students. Thank you so much for watching this lecture. Keep smiling, take care, and bye bye.